Good. Okay, I'm going to go ahead and get started. Sooner begun, sooner ending, especially given the time. My name is Brian Langley. I'm the program manager for D3D, HLSL, and also the graphics tools effort. Also helping me with this are going to be Mike Riches and Matt Sandy, who you've probably seen since we've paraded him out for just about every graphics presentation we've done in the last day. One of the things before we get started is I'd like to just get a show of hands, because given our somewhat manageable crowd, one of the guys on my team has offered to teach us all salsa lessons. So if you guys would rather leave had enough code for today, we can all just kind of get back and learn a few new things outside of the land of code. But just kidding. I mean, actually, that might not be too bad of an idea, but we'll be around. We can do that afterwards if you guys are interested. So in terms of who you are, besides people that have an incessant appetite for more technical content when there's bars open, and I heard it from an inside source that the place to be is Annabelle's. So if if you're looking for a place to go, that's evidently the best place in the area. But what really motivated this talk and why we decided to give it is that there's a tremendous amount of content out there for DX9, and as a gamer, I know that a lot of my favorite games were written on DX9. They haven't been updated in a while. And when we look at the wealth of content that is out there right now and available to customers, we would really like to see that come onto the Windows Store. We think there's great value to be had for both customers and also for developers. So that's really what's motivated this talk. Now, we do have other solutions in Windows for people that are not from DX9, and we've spent some time today talking about the pure DX11 side of things, and we also have middleware solutions for people that are familiar with developing in C# and XNA. But the focus for today's talk is going to be on helping you to bring your DX9 content over to Windows Store, including all of the other things besides the actual graphics that have to be in place in order to make that happen. And so if I could, and this is actually a real poll, not unlike the last one, if I could I just get a show of hands of how many of you actually have DX9 content that you might be interested in porting? Okay, so for the rest of you, I promise it's going to be a super, super easy port. And for the people that do have DX9 content, I promise it won't be too painful. So in terms of how we're going to go about this, I'm going to talk about a few things. The first thing I'm going to do is essentially give you some rationale. So why should you want to do this, right? I mean, other than you have Microsoft telling you it's a good idea, like what motivates you to take your 9 content and bring it over to 11? I'm trying and briefly make a case for that. Then I'm going to talk through each of the different components that are necessary in order to take that PC game and migrate it over to the Windows Store. And the way that's going to work is Matt and I are going to talk a little bit about the different conceptual pieces that have to be in place, just sort of how to think about the changes that we've made in our platform over the past 8 or 9 years. And then Mike is going to come and show you actual code examples of how to do that with as close to real world as we can get in a 1-hour presentation. The key thing, though, that I want to make sure that everyone takes away from this is that while it's not a Herculean task to do this port, it is more than we can cover comprehensively in an hour. So really the goal of this presentation is to let you know what the key things are that you need to do, and then give you the resources that you need in order to go off and complete the work. And we'll have for that reason, we've got a pretty extensive resource slide, and we've updated a lot of our documentation to help you along the way. And obviously, we're available for questions as well. One quick thing about questions is, given the time, we will be around to take questions afterwards, but I'm not going to do an open mic just to let people get out of here that want to get to the party at 7. Okay, so why would you want to bring your game to the Windows Store? Well, possibly one of the most important reasons that you want to bring your game to the Windows Store is because, as we've proven, we will keep bugging you about it until you do. And we're very tenacious, and we will not let go. We will continue to give this presentation until we see all the games we want in the Windows Store. But that aside, just looking at the numbers, we believe there's a really strong case and a very compelling story here. Just looking at the sheer volume, we've got 100 million strong and growing. That number is the sales that we've had of Windows 8 that we announced not too long ago. Obviously, those are really big numbers that we're talking about. If you sit back and think about other types of platforms, there aren't that many that have hit that number, and we're there after less than a year. And so when you look at just the volume, there's a really compelling story there to bring your game over to Windows Store. But it's not just a numbers game either. If you look at the types of experiences that we've brought over to the Windows Store with the advent of the proliferation of touch devices and convertibles, people are using their PCs in ways that they never have before. And what we're seeing is that that's leading to new eyeball minutes, and if that's tapped properly, that translates into new sources of revenue for you. So we think there's a really strong financial incentive for making this change. Obviously, there's new platform features and performance. You guys are probably sick to death of hearing about this, but we've got more to come to tell you because we've done an inordinate amount of work in this last year. But the things that you've heard about today, many of them are only available if you move your game to the Windows Store. And finally, and this is kind of a near and dear thing that I actually happened to talk about during lunch today with some people, we've got a trusted app distribution platform, and the thing that a lot of people don't realize is that you can actually use your own commerce engine in the Windows Store. You don't have to use the Microsoft provided one. And if you don't use the Microsoft provided one, you don't pay Microsoft for it. So a lot of the negative, some of the negative misapprehensions that we've seen about, oh, Microsoft's going to cut into my revenue, that's only if you use and we think it's good and we're trying to make it even better, but it's not required for you to use it. And when I was meeting with some, just randomly when I had lunch today, I was talking with some independent software developers, and they were absolutely floored. They didn't believe me when I told them this. I had to take out the documentation on MSDN and show them, in fact, there's middleware vendors that are coming to provide other billing services. So this is a big misapprehension that I think it's important to be aware of. And the things that I've said thus far are really focused more on the benefit side of things. So, what are the benefits that you get if you bring your game to the Windows Store? And obviously, as all of us make decisions, there's a reason why it's referred to as a cost-benefit analysis and not a benefit analysis. And so when we look at the cost that you'll incur to bring your DX9 content over to the Windows Store, we actually believe that that's a relatively small and manageable number for the simple reason that the vast majority of the work that you've already created to make this DX9 content, it continues to be applicable in the world of DX11. And we're going to talk about that a little bit more here. So if you look at things like art assets and media assets that are significant fractions of overall development cost, those things continue to port over. There's very little, if anything, you have to do to continue to make use of those when you move to DX11 and the Windows Store. Gameplay is very similar, except that now that we've enabled new experiences, you may want to do more. Your existing experiences will continue to work, but we also give you the opportunity to do that. And then there will be some effort to bring over the graphics and audio input model, and now that we've got a new packaging story, that will take some effort. But when we look at the overall cost required to move these games over to the Windows Store, we believe that it's quite manageable. So now I'm going to talk a little bit about the graphics side of things, and we're going to spend the majority of the presentation talking about the graphics because we believe that's the most critical piece and also the most complex. I'm going to start out by talking about, why would you use D3D11? Well, again, one of the most important reasons is that it's required. So if you want to be in the store, you've got to use a D3D11. But there's a lot to recommend D3D11 beyond just the fact that you need it to get into the store. When you think about the breadth of support that you receive when you develop for D3D11 in terms of just hardware availability, it's hard to compare with that. When we talk about PC graphics hardware, just last night I was looking on Steam and looking at some of the statistics there. And if you look, like roughly 99-ish% of the hardware out there is from DX feature level 9 and above, or at least the people that are relevant to playing a lot of the games that you guys create. And so you get to leverage all of those hardware pieces, all those different generations of hardware by targeting DX11. You also get to utilize phone and Xbox. So those are additional things you get by targeting that API. It makes any type of porting go much more smoothly. Also, you've got broad OS availability, so everything from Vista, if the user has been keeping track of their service packs, all the way up to 8.1. new features and enhanced performance we've been talking about all day today. And then finally, D3D11 is really a more streamlined programming interface. It's sort of more tight conceptually. Things are just, they make more sense because they have a better reflection of the underlying hardware, and I'll talk a little bit more about that shortly. And the other really important reason for why you should bring your game to DX11 is that we're still actively investing in this API, and given the vast number of hardware and software out there, we will continue to do so. And moving to DX11 allows you to benefit from those future enhancements that we make. So that's the reasons why you want to move to D3D11. But now let's get into what does that actually entail, and what are the differences between D3D9 and D3D11. So with most graphics things, I'm going to start out with just a pipeline view of what the overall graphics pipeline looks like. And this is, you can think of as the simplest migration from DX9. So you'll notice that the vast majority of this is going to look very familiar to you. We've formalized a few steps, so things like the input assembler and output merger, we've formalized those steps, but they're basically doing the same thing. The one thing that you will notice is missing here from DX9 is the fixed function pipeline. Vertex shaders and pixel shaders allow us to do everything that those could do and a lot more, so those are obviously no longer part of the pipeline. We do have samples that help you if you need to port your fixed function code over to shaders, but that's really the only big difference if you're moving from DX9 to DX11 in terms of just getting things up and running. Now, once you're up and running, then we've got some extra functionality that we think will really delight customers and provide some amazing experiences. I'm not going to go into a whole lot of detail on this just because this is really about just helping you to get your code ported over. But we do have geometry shader and a lot of things that go into tessellation, which will then allow you to create really incredible surface experiences or experiences on surfaces of objects and whatnot. When you mix them with displacement mapping, you can produce some super amazing effects with very little rendering cost. So now I'm going to kind of go into a little bit of the key conceptual differences between D3D11 and D3D9. So as I mentioned, we've redesigned the API to more closely reflect the underlying hardware. And the first key element of that is that we've taken the DX9 notion of a resource and we've broken it out into two logical pieces. So a DX11 resource basically just contains the actual bits of that resource, and then to do something with it, you have to do what's called have a view control on top of that. So once you have mapped this view to the resource, then you can do things like make it a render target or whatnot. So we've taken this combined thing of resource and disaggregated it out into these two logical pieces. The other thing that we've done that doesn't require a tremendous amount of work on your part, but is we've taken the GPU and the memory and we've virtualized it. The reason for that is now that every store app is essentially a GPU app, we had to do something to make sure that all of these pieces or all of these apps play nice together. And so as far as your app is concerned, the only difference you're going to see is that you don't have to deal with that lost device that you used to get whenever you have to Alt-Tab out, because all the resources have now been virtualized. But that's something that the rest of that is just behind the covers and you won't have to worry about it. And the final thing that is a key difference to be aware of is that we've separated out the low-level task, which is basically, we've called that the DXGI piece, and the 3D runtime piece. And I'm going to talk a little bit more about that shortly. So Mike is going to go over this in more detail, but I'm just going to give you just a brief flavor of some of the differences in APIs. You can see that whereas in DX9 you specified a specific kind of resource, in DX11 it's a more general type of resource specification, which you will then give a bind type and then bind that to the pipeline through creating a view on that particular resource. So now I'm going to talk a little bit about DXGI. DXGI is our functionality that essentially accomplishes all of the low-level tasks, such as enumeration, swap chain creation, changing the gamma, all of those low-level things that are fairly independent from the D3D side of things. And the key things you need to be aware of when using DXGI is that we've simplified a lot of the interaction when there's a when to change state. So things like when there's a resize, you don't have to do nearly as much as you used to. Basically, the DXGI will take care of setting the front buffer. All you have to do is call resize buffers, and you'll be good to go to set the to resize the back buffer. Also, things like the window pane and borders, you don't have to worry about setting those anymore. DXGI will take care of those. Another thing to note is that unlike in the past, when you could change what swap chain was bound to a particular window or a device at any time, now those are bound at creation. That allows us to do some optimization and allows things to generally go faster. And finally, we require the use of flip mode because that is essentially saves a copy by the DWM. Rudy was talking about that earlier in the debugging talk, if you were there for that one. And again, just some differences to show how some of these mashed together things in DX9 have been disaggregated to make an overall cleaner interface. So now I'm going to briefly touch over the notion of devices in context. So in D3D9, this is very similar to resources and views, where we've taken the notion of a D3D9 device and disaggregated it out into the device and the context. Now, the device is basically where you create your API objects and your resources, also where you free them up. So it's really focused on resource management now, whereas the context is focused on having the device actually perform commands or operations. And so we've taken these things and spread it out or disaggregated them. What that allows us to do is the D3D device object is multi-thread safe, so you can hit that with as many threads as you want. The context, however, can only be called on by a single thread at a time. However, if you do want to do multi-threaded rendering, there are more advanced ways to do that, but that's significantly beyond the scope of this presentation. So now I'm going to talk a little bit about the notion of feature level. And I mentioned this earlier on and kind of talked a little bit about it. But basically, the problem that we were trying to solve with this is this giant tangled mess of caps bits that you had to deal with in the past. And the way that we've solved that is we basically have every piece of hardware has a particular feature level that is associated with that is determined by what features that hardware supports. And so you can think of it as if the hardware supports the features that came out with a particular API version, it'll have that feature level associated with its particular hardware. And what that means for you is, as app developers, is that you don't have to deal with a huge giant jungle of caps bits. Instead, you can basically just specify what feature levels your app supports, and then we will then, as the runtime, give you back the most capable feature level that the user actually has on their system. So basically, you tell us what you want, and then we will tell you the best that the user's hardware can do. Now, the thing to be aware of is that when you're doing your port, we recommend that you port initially and just support 9.1 because that's going to be what you're used to and what you know. And then after you've done your port, you can then add some of the extra features that are present if you want to utilize those to provide a more compelling experience for users that actually have that hardware. So shaders are another element that have changed. The first key change is that since there's no longer any fixed function pipeline, any rendering that you do is going to require the use of shaders. All of the shaders have the same instructions. They access the same resources. So they have what's known as a common shader code. Now, unfortunately, you can't take your existing shaders from DX9 and just have them automatically work. You will have to recompile them in Shader Model 4.0 or greater. We are shipping the compiler in the System32 directory this time around, so you won't have to worry about redist if you're focused on making a Windows Store game. So that change has been made. And also, we have this notion of a constant buffer. And essentially what the constant buffer is it saves you from having to call this API every time you want to use your pixel shader or vertex shader. Instead, you create this buffer full of the constants that you need. And when you construct your buffer, you want to make sure that you're grouping them in a way that's based on access. So that if you're having to bring memory in, you want to make sure that you're bringing in the right memories to minimize the overall fetches that are necessary. And the other change to be aware of, if you haven't heard it already from the earlier talks, is that we now have the ability to do runtime linking. So you can compile at development time, and then you can, when you're going in actual runtime, if you're having to deal with the, if you had in the past to deal with the combinatoric shader issues, you can now link those together in runtime. We do also support runtime compilation. However, that's a lot slower than runtime linking, and so we highly encourage you to use runtime linking if it's at all possible for you. So the other things to be aware of, and these are just sort of little gotchas that used to exist in DX9 that are now fixed. The first is the gamma side of things, and Rudy also mentioned this in his debugging talk. And basically, DX9 hardware handled gamma incorrectly. It blended in gamma space instead of pixel space. And so the workarounds that you had to do to make your gamma work properly, you no longer have to do. The other thing that was a bit of a gotcha in DX9 was that you had to subtract half a pixel from your vertex pixels because of the way that we used the square render target and how we had that center in on the center of those squares. We fixed that behavior in subsequent versions of Direct3D, so now you no longer have to do that, that half a pixel subtraction that you had to do in the past. So with that, I'm going to hand it over to Mike, who is going to give you a demo of porting a sample application from DX9 to DX11.
Thank you, Brian. So in this demo, we're just going to look at a very simple example program. So in this case, we're just going to look at a very simple renderer that draws a cube in a desktop window using Direct3D9, and how to implement that same renderer in Direct3D11 in a Windows Store app. So the first thing I want to, or actually I should explain, we're going to talk about in particular how to understand where things that you would do in the Direct3D9 device interface, you've got to do those now in the device interface or the device context or the swap chain. And I'll go into more detail about that as we go along. Okay, so the first thing that you would do if you were writing a Direct3D9 app is you would get the device capability bits. Then you would go on to create the device interface itself. At this point, you would need to specify important parameters such as the swap chain backbuffer format, whether or not you're going to use multi-sampling, and the D3D swap effect. Then you would call create device and get back a pointer to a Direct3D device that you could use to create resources, render a frame, and also swap the backbuffer to the front. Now, in Direct3D11, you don't have to deal with capability bits anymore. You get to enjoy the benefit of feature levels. All you have to do is provide a list of the feature levels that your game can support and call D3D11 create device. What this will do is it will tell you which hardware feature levels that the device can actually support, and then go ahead and give you a pointer to the device and the device context. Now, note that we didn't specify any swap chain parameters. That's because we're going to create a swap chain next using the DXGI API instead. So let's take a look at how we do that. We need to go ahead and create a swap chain description structure specifying the parameters that we need. For example, the backbuffer format, whether or not we're going to enable stereo, the flip mode, and whether or not we're going to enable any kind of scaling. Now, in order to create a swap chain properly for this device, we need to get access to the DXGI factory that created the Direct3D device and the DXGI interface for it. So first, all we have to do is get the DXGI device interface from the Direct3D device. Note that we're using COM pointer, smart pointer wrappers for the COM interfaces for Direct3D now. This means that instead of calling query interface, you can just use the .as function to give it a pointer to the proper interface type, and it will give you back that interface for the Direct3D device. It's pretty easy. Then from there, you can call get adapter to get the DXGI adapter that owns the device. And then from there, you can get the adapter's parent, which is the factory that you use to create the swap chain. Now, you can go ahead, or excuse me, at this point, you go ahead and create the swap chain and set the frame latency. And this also creates the back buffer in the format that you requested. The back buffer is a Direct3D resource. So again, this is just one part of the equation. You also need the other logical piece, which is the resource view. In this case, the resource is a render target, so we create a render target view. And we can provide that when we begin drawing, and that will start a drawing operation. So this also gives us the information we need to figure out the viewport. We know the back buffer width and height, so we can specify that. We can use that to get the aspect ratio and create a perspective matrix. Okay, so now that we have the device context, and the swap chain, we have everything we need to start loading resources and then go draw. Now, the Direct3D device is used to control device resource allocation and destruction. So let's look at how we can load some resource. First, I want to talk about loading shaders. In Direct3D 9, I know that a lot of the time people usually compiled shaders at runtime, which is okay, but it's not as good as pre-compiling your shaders in Visual Studio. If you do that, then you don't have the difficulty of waiting for shaders to compile while you're loading or causing gameplay hitches, that kind of thing. So in order to do this in Visual Studio 2013 Preview, all you have to do is add your HLSL file for your shader to your project and make sure to specify the right type of shader and the right shader model. In this case, shader model 4, level 9.1. Now, this is important because when you go to load the shader, it will actually validate the shader model against the feature level of the Direct3D device. So if, for example, I was trying to load a shader model 9.3 shader on a feature level 9.1 device, it would go ahead and give me an exception if I tried to make this call. Thankfully, we're not trying to do something like that, so this will succeed. The next thing that it will do, after validating the shader, allocating a resource for it in graphics memory, and loading the data in, is it will allow us to validate the input layout we're going to use for the input assembler stage with the vertex shader to make sure that we're giving it geometry in a per vertex data structure that's compatible. We also need to create a Direct3D resource to store the constant buffer for the vertex shader, additional constant buffers for any other shaders that also need them. In this case, we just have the one. And we're going to also load the pixel shader. So I also want to mention very briefly about geometry. Vertex buffers and index buffers are resources in graphics memory, another kind of Direct3D 11 resource. The difference really between Direct3D 9 and Direct3D 11 for vertex and index buffers is that you don't need to lock the memory and do a mem copy anymore. You just tell the Direct3D device where the vertex buffer is in system memory, and it will go ahead and copy it for you. So those are all the resources loaded in this example. I'm going to talk about how to draw a frame. And in this case, we're going to go on to use the Direct3D device context. Now, since this doesn't use multi-threaded rendering, it uses an immediate context. And I'm going to point out one important difference here. Note that in Direct3D 9, we would start with begin scene and end with end scene. This isn't how it's done anymore because it's going to match much more closely to what the hardware is doing. So in Direct3D 11, to render a frame, all we need to do is set the render target, clear it if this is our first drawing pass, and in this case it is. You provide the vertex data and the index data to the input assembler stage, tell it what kind of primitive topology you're using, and provide the input layout, in this case that we created previously, and that was validated with the vertex shader. We set the vertex shader and the pixel shader, tell it which constant buffers to use, and proceed to call one of the drawing functions on the context, in this case, draw indexed. Now, we created the constant buffer earlier, but I haven't talked yet about how to actually put data in it. In order to do that, you need to call the update sub-resource function on the Direct3D context. This tells it to update the data in the constant buffer with some new data from system memory. In this case, for example, we're telling it to rotate the cube 1 degree per frame. So that's it for drawing a single frame. Now that the frame is drawn, we're ready to call the present function. We do this on the DXGI swap chain now. Before, in Direct3D 9, we would just have the device present the frame. Now this is controlled by the swap chain, and it will be able to draw the cube. And we can put it side by side with the other one and see that it's the same. And that's it for the graphics part of the demo. So back to you, Brian. Yep.
Thanks, Mike. Okay, now that we've talked about and seen in action how easy it is to port from DX9 to DX11, I'm going to talk briefly about 2D and audio. On the 2D side of things, currently, if you're using, if you do your 2D using Direct3D, we highly recommend that you consider using Direct2D going forward. Direct2D has some awesome functions for doing 2D geometry and some amazing things for text and imaging. The key thing to be aware of there is since Direct2D is built on top of Direct3D, you're not going to have to deal with any performance issues. It's the same super lightning fast speed that you're used to seeing with Direct3D. The other thing that works really well in combination with Direct3D is XAML. There's been a number of talks today on XAML, including one about how to use it with Direct3D. And the key thing to take away there is that if you want to do a lot of UI in your app, then you may want to investigate using XAML. It interops excellently with D3D, and you can get the same lightning fast performance and also make use of the XAML UI infrastructure if you decide to do that. XAML presentations already happened, but all these things are going to be available on the web. Okay, so as captivating as amazing graphics can be in a game, it's just one part of it. There's a lot of other cool things that need to happen in order to give the user a fantastic experience. And audio is one key portion, and we want to make sure that we give you some of the basic building blocks so that you can incorporate that into your game. There's essentially two important APIs that you need to be aware of if you want to use audio in your game. The first is XAudio 2, and the second is Media Foundation. Now, XAudio 2 is a very low-level API that essentially just takes uncompressed audio buffers and plays them back. And you can do things a little more fancy than that, but at the nut of it, that's what XAudio 2 does. Now, Media Foundation is useful in that it can take a variety of different types of compressed audio and decompress them into the types of buffers that can then be used by XAudio 2 to get them onto to actually play those things back. So when you think about it, when you want to play a sound effect, Xaudio 2, you can pretty much use that directly because typically effects are small, they're not taking up a lot of space. If you want to do something like background music where it's going to be stored in a compressed format, we recommend that you use Media Foundation. And we do have a sample available called Marble Maze that has a helper class to help you to use that. And so that's well documented and it's online. You can grab that at any time. Goes without saying that there were a number of third-party audio frameworks for Windows 8, and those will continue to work for 8.1. And this is just a brief code sample of Xaudio 2, and the reason that I included this here is just to illustrate how simple it is to use. Especially getting these uncompressed buffers and getting the playback is extremely simple. Literally, this is all the code that you need in order to do it. Getting that added to your app will take very, very little time. And so with that, I'm going to hand it off to Matt, who is going to talk to you about input and events.
So now that you know more about how to port your graphics and audio code to the Windows Store, it's time to talk about the windowing model. Now, this actually applies whether or not you're currently using DX9 or DX11. It equally applies for both of those when moving to the store. So one of the big changes when you move to the store is that instead of having HWinds, you now have this core window object. Now, this basically serves the same purpose as the HWind. It represents a window, typically full screen for a game. It has size, focus, and visibility properties, and it's the object through which you receive events. Now, there are some conceptual differences between the core window and the HWind. One of those is that instead of traditionally with the HWind, you, the application, create the window itself, with the core window model, the OS gives you an application window with which you are to paint your graphics into. The main difference is that you don't really have control over the size of your window. Instead, we leave the size control up to the user. So instead of supporting, for example, a fixed list of resolutions, with core window, you should be prepared to accept any arbitrary resolution for your window size. So going into more detail about how the core window receives events, unlike at HWinds, which receive events through, for example, WMMove, core window receives events through event handlers. So there are several event handlers on the core window object. The two most common ones you'll be using are the key ones and the pointer ones. So you should register for these events first, just to get your game up and running so you can get mouse and keyboard input working. Along with these event handlers comes with a different method for actually processing these events. So unlike the standard getMessage and peekMessage APIs you'll use for HWinds, with the core window object, you'll actually use the processEvents API on the dispatcher. Now, the dispatcher itself is a property of every core window. And there is actually a one-to-one mapping for the old APIs with the new core window APIs. So one of the arguments to process events is an enum. And for example, if previously you used the peekMessage API, now you will use the processAllIfPresent enum when calling process events. The behavior of this API is that it will process all events that have been enqueued since the previous call to process events. But if there are no currently enqueued events, the call returns immediately. Likewise, getMessage has an equivalent API, and that's the processOneAndAllPending enum. This is similar to peekMessage in that when called, it processes all events that have been enqueued since the last call. The only difference is that if there are no queued events, like getMessage, processOneAndAllPending actually will yield the thread until at least one event comes in. This is actually useful if you want to save power, for example, if you're running on a tablet, because what you can do is if your window has lost visibility, for example, you can actually start using processOneAndAllPending so you can yield your thread, which will reduce power consumption. It will obviously continue to receive events, so if you start receiving more events, you can move back to the processAllIfPresent option. Now, there is a third enum that doesn't really have a corresponding HWind API, and that's the processUntilQuit enum. If you've created your game that you're actually spinning up multiple threads, for example, to run network, audio, and graphics, this is actually the API to use. Because what it actually does is it will cause the UI thread to yield indefinitely for the duration of the lifetime of the app. But if you've spun up your threads to run your other parts of your engine, you don't actually need the UI thread anymore. You can use processUntilQuit to allow the UI thread to just process events. So now that you know more about how core window works in the event model, I'll hand it back to Mike, who will actually show you how to use this in your code.
Thank you, Matt. So in this next part of the demo, we're going to look at the same example, and we're just going to look at how the windowing code corresponds between the two implementations. So here in the Direct3D9 desktop app, you can see that it just starts with a WinMain function. This calls an initialization function for Direct3D9, creates a new window, creates Direct3D and Direct3D device resources, and then goes into main loop, processing messages and rendering frames. In order to do this, it needs to create an hwind, going through the usual sequence for that, specifying window size, window title, calling create window, and getting back a window handle. Then, of course, we have to have a static message processing function. In this case, it's pretty simple. It just processes window close events and window destroy events, but of course, in a real game, this would be a lot more complex. In the Direct3D11 Windows Store version, things are a little bit simplified because we just have to live within the bounds of an iFramework view implementation. We put the app in an iFramework view class and just implement the 5 virtual methods that are required for that. We have an initialization function here that is called, that allows us to create device resources. We have a run method. This is where the main loop is hosted. You can see here that this is where it calls the core window dispatcher and provides process all if present. And as Matt mentioned, we need to be prepared to live within a window that can be resized at any time, or even get a new window provided to us. In this case, we register for the set window function, or we have a set window function that registers for also the size changed function. Both of these methods will call a method we have implemented called create window size dependent resources. This is actually the code we saw earlier that creates the swap chain. It also has a code path that can resize the swap chain if it's already made one. So for example, that's what will run if I take and place the window side by side with the desktop version. It also has an uninitialized function, and you can see here that this is the event handler for window size changed. Now, in order to do things like process input, you'll register for additional event handlers, and more about that in the coming slides. Okay, back to you.
Thanks, Mike. So let's talk a little bit more about input. So as I mentioned, all the various input types that you traditionally would receive through window messages, you now receive by registering and implementing event handlers for various functions. In addition to the key down and key up events, you have this pointer point API, which includes the pointer pressed, pointer moved, and pointer released event handlers. And what's nice about this is that although it's a requirement to implement touch support for your Windows Store apps, the pointer point API actually provides a unified API for all precision input types, including touch, mouse, and stylus. So even if you just think about mouse code, you'll automatically get touch support for free. Although if you do want to provide different experiences for each of those input types, you can check for the type of input device using the pointer device type in the arguments to the event handler. Additionally, there are some input device specific types, such as mouse wheel moved and mouse moved events. In particular, the mouse moved event, which applies only to mouse, is particularly useful for implementing first-person camera controls, as you would find in many first-person shooter games. So let's talk about that in a little more detail, specifically mouse look controls. Now, typically you'll need this type of control in a first-person shooter game, but many other games have it in various scenarios as well. And really the key is the mouse moved event, because instead of returning the absolute position of the mouse on the screen, the mouse moved APIs return the relative position from the previous frame on the screen. This allows you to disassociate the actual position of the mouse with the qualitative movement where you're actually using it more like a joystick to control your view rather than absolute positioning. Now, this works well enough if you just register for the events, but what ends up happening is if you move the mouse into a corner, or if you have a multi-mon system, you can end up moving off the window altogether, and instead of firing your weapon, you'll end up deleting your email. So in addition to this API, we also allow you to, using a property on the core window object, you can set the cursor to null. What this does is normally this hides the cursor, but if you've also registered for the mouse moved handler, it will actually lock the cursor to a fixed position on the screen and be invisible. This allows the user to move their mouse all over their mouse pad and provide input to your camera control without risking moving off the screen and accidentally clicking on things they didn't mean to. Now, we have some examples of samples that we've shipped that show how to use this, including a shooting game example sample and also a touch input sample. Now, one thing to be aware of is that when you're implementing your mouselet controls for Windows Store apps, be considerate of the user's wishes. So, for example, if the user has Alt-tabbed out of your app and your window has lost focus, if they Alt-tab back to your app, don't immediately set the cursor to null, because then the mouse will get trapped and they don't really see why that happened. Instead, wait for the user to actually click on your app's window first, and then you can take back control in this mode. So now that you know how to implement your traditional mouselet controls, as I mentioned before, one of the requirements for the Windows Store is supporting touch. So you may be asking, how do I support a first-person camera control using touch? Well, one of the most common implementations is to use virtual thumbsticks. Many phone games have this type of control scheme as well. But something to keep in mind for Windows Store games is that you're not always guaranteed to be on a 4-inch screen. So what you can do is you can use actually DPI as well as information about the size of the display to appropriately scale your virtual thumbsticks. Or if you want to take the easy way out, you can just make the size and position configurable by the user so they can set it up themselves. Now, there are several approaches to implementing virtual thumbsticks. One of them is simple fixed positioning, where the thumbstick is always on the same position on the screen every time. Another is to make it basically a floating point where wherever the user first touches the screen becomes the center of the virtual thumbstick, and then as they move their thumb around that point, that provides the input to the control system. But we actually prefer and recommend sort of a hybrid approach, which I'll explain in the next slide. So similar to the start at center point, when the user first touches the screen, you start the virtual thumbstick at the very center of the touch point. As they move their thumb within the region of the virtual thumbstick, that provides input to the program. But as the user moves off the border of the thumbstick, you actually end up dragging the center with the thumb. This allows the user to, for example, if they are running away from a bunch of zombies and they end up forgetting, conceptually in their head, they're not looking at the thumbstick. They end up forgetting where the 0 point is. If they end up finding a zombie behind them, they might want to quickly do a 180. But at this point, because they've been holding down so long, they forget where the 0 point is. And if you're not dragging the center along, the 0 point may be way up in the screen. But if you drag the center point, they always know that they have to move, for example, ½ an inch back up to move to the 0 point and flip directions. So that's how you implement your mouselet controls using touch. But a third input type that's supported for Windows Store apps is Xbox controllers and controllers in general. You do this by using the Xinput APIs. This supports the Xbox 360 controller, among others. And also, for those of you who have already used Xinput in the past, starting with Windows 8, this API is now in the box, which means you don't have to ship a support DLL along with your game. Now, one notable difference about Xinput versus the other input APIs is that Xinput is query-based, not event-based. Now, as a side effect of this, what this means is that when you're controlling your game with a controller, input events don't actually end up resetting the inactivity timeout for the system. So if the user is controlling their game entirely with a controller, the screensaver will turn on after 15 minutes without any intervention. But what you can do is you can actually use the display request active API to manually trigger an inactivity call that says that the user is using the application and the system is still active, so don't turn on the screensaver, don't turn off the screen. We have an example sample that we've shipped that uses Xinput called Controller Sketch, so I'd encourage you to check it out if you're interested. And just to give you an example of how easy this is to add to your application, using a demo that I wrote for one of my other sessions, I already added touch move controls, and adding Xinput took no more than 10 minutes, literally, to add this, using the code from Controller Sketch. So in a nutshell, support multiple input types. Gamers will definitely like this. Personally, I prefer to use mouse and keyboard when controlling infantry, but if I happen to jet, I want to be able to pick up my Xbox controller and control my jet with the controller. And a lot of gamers want to have a similar experience. So one thing this means is that you want to allow a seamless transition between your input types. Don't require users to go out to a settings menu to change what input type they're using. It's a good idea to allow them to just seamlessly move between them. Now that I've talked about input types and things that you'll have to do when moving to the Windows Store, I'm going to talk about some optional things to really make your games light up in the store. One of these I'm sure you've heard a lot about is called live tiles. You've probably seen the ads all over the place. Every poster has live tiles. But it's a really unique opportunity for games because in particular, games have an opportunity to provide really rich information to these live tiles. So what is a live tile? Well, for a quick review, it's basically it's a system where when the user goes to the start screen, live tiles provide you the opportunity to provide programmatic updates to the content. So instead of having a static image that represents your application on the start screen, you can actually update it dynamically, either programmatically with your local application or with a web-based service to update the tile to whatever content you want. So just an idea to get you started, if you're in, for example, a massive online game and your player is a part of a particular faction, you could, for example, have your live tile represent an area control map of the entire world. So even if the user wasn't intending to play your game, they might end up going to the start screen and say check their mail, but they end up seeing your live tile that you have updated that indicates that their faction is maybe losing territory to the enemy faction. So they might say, oh man, I really got to go help out my team. They click on the tile and start playing the game. Now, one of the other new features for Windows Store apps is notifications. So this is similar to live tiles in that you can provide XML-based content updates either programmatically or with an online service. But this is used for more urgent notifications. So instead of being a passive update that the user only really sees if they go to the start screen, notifications pop up immediately in the top right of the screen. You can use this to display incredibly urgent information to the user, such as their base is actively being attacked by one of their friends, or I guess enemies in this case. And one of the opportunities that you have when using notifications is that when the user actually clicks the notification, you can actually bring them specifically to a certain point in your game. You don't have to bring them to the menu screen. You can bring them to a specific entry point. So in this example, you could bring them right to their base that's being attacked, and they could get into the game immediately where they need to go. Now, one thing that's important to note is that notifications can be disabled by the user on a per-app basis. So definitely save them for urgent notifications only instead of spamming them. Otherwise, they might just turn it off for your game. So that about wraps up our talk. We've got a bunch of resources that we can point to. So I'll leave this up for a couple seconds so you can take screenshots. But the slides will also be available online later. Got another slide of resources. So definitely check these out for more information. We've got a lot of great samples that have this as well. And got a link to session evaluations, which are also online. So thanks for watching. And we'll be up here to take questions after the talk. So thanks.